I need to tell you something complex. It's about complex numbers, not these fancy computer screens. But speaking of those, my wife uses them to visualize effects she makes for video games. Sorry, I'm about to get ahead of myself. Let's look at the schedule. As you can see here, we're on topic 6, complex numbers. The thing is, video games are complex. Creators use real equipment to create an imaginary world, and players experience an imaginary world in a real one. Wow, that's deep. We're on lesson 6, complex numbers. There's only one lesson in this topic, and you could follow along using this document. Oh, and I forgot to mention, this is the Introduction to Advanced Algebra 2. I'm Mr. Stark. I would like to introduce you to complex numbers and their operations. Student, here is complex number a plus bi. A plus bi, I would like you to meet student. Student, I can't promise you that your relationship with complex numbers will be normal, because A is real, but I is imaginary. Complex numbers is the set of real numbers and the sum of reals and multiples of I, an imaginary number. I, my dear real student, is the solution to I squared plus 1 equals 0. So therefore, I squared is negative 1, and I is equal to the square root of negative 1. Ooh. Let's get to know the operations of complex numbers a little better, and then we'll see how they come into play with a quadratic equation. Adding complex numbers goes like this. Let's say you have a complex number, a plus bi, and we're adding it to another complex number, c plus di. A, B, C, and D are real numbers. We add the real parts, so A plus C. Then we add the imaginary parts, BI plus DI, which can be written as quantity B plus D times I. Subtracting complex numbers is pretty much the same, just with subtraction. So we have A plus BI and C plus DI again, but we subtract them. Then we get A minus C and B minus D, I. If you practice doing some problems like that, you should be good. Multiplying complex numbers gets a little more interesting. Let's do this example together. We have 3 plus 2i times 4 minus I. We just need to multiply these two binomials together, so we distribute. Multiplying the first terms, we get 3 times 4 is 12. Multiply the outer terms, 3 and negative I, to get negative 3i. Multiply the inner terms, 2i and 4, to get 8i. Then we have the unique one, 2i times negative I, which is negative 2i squared. Now we can simplify. So we have 12, negative 3i plus 8i is 5i. But what is I squared? Well, it's the square root of negative 1 times the square root of negative 1, which is negative 1. So we have negative 2 times negative 1. Now we can simplify again. Negative 2 times negative 1 is 2, plus 12 is 14, so we have 14 plus 5i, which is in the form of a complex number, a plus bi. So far we know what I is, we know what I squared is, but what's I cubed? I cubed is negative 1 times I, so we have negative I. So what's I to the fourth? It's negative I times I again. So then we have negative I squared. Okay, this is getting a little crazy, but if we square I, order of operations, we get negative 1. Multiply by negative, we get positive 1. So now we know what I squared, I cubed, and I to the fourth are. If I to the fourth is 1, then I to the fifth is I, and then the cycle just repeats itself. I have one last little thing about the operations with complex numbers, and it's called the conjugate. Just jot this down and then we'll see it show up later. If z equals a plus bi, so z is a complex number, then the conjugate is z bar. It's z with a little horizontal bar over it. That's equal to a minus bi. A plus bi and a minus bi are conjugates of each other. Now let's revisit the quadratic formula and see how complex numbers can show up. The example says to solve x squared plus x plus 1 equals 0. Seems easy enough, right? A is 1, b is 1, c is 1. Well, we'll see. But I have one thing to share with you before we do that. It's called the discriminant. b squared minus 4ac, the expression inside the root in the quadratic formula, is called the discriminant. It tells us if the solution will be real or not. We'll come back to that idea once we set up the quadratic formula and simplify a little. Here are the solutions. X equals -1 plus or minus the square root of 1 squared, b squared, minus 4 times 1 times 1, minus 4ac, all divided by 2 times 1. We can simplify that expression in the square root, so we get x equals -1 plus or minus the square root of -3, all divided by 2. There it is, the discriminant. It's -3. And since the discriminant is negative, the solutions will be imaginary. Let's rewrite those solutions using I. We have x equals -1 plus or minus the square root of -1 times the square root of 3 divided by 2. The properties of square roots allow us to do that. Then let's just replace the square root of -1 with I. So we have x equals -1 plus or minus I root 3 divided by 2. We can also write those solutions as -1/2 plus root 3 divided by 2 times I, and -1/2 minus root 3 over 2 times I. The next thing we'll do is check these answers on the TI-84 graphing calculator. I'm on the TI-84 calculator. You can follow along. First we'll go to mode and change it to complex mode, a plus bi. Press enter. Then we'll go to the main screen, second mode, and enter one of the solutions. So open parenthesis. We'll just enter the positive solution, so we need a fraction, alpha y equals, enter. Then we'll enter -1 plus I root 3. I is second period at the very bottom. I root 3. Then we'll arrow right to get to the denominator and enter that 2, and then arrow right to close the parentheses. So that's what we want to square, because part of the original equation is x squared plus x plus 1. Now we do it again. Plus, open parenthesis, and then the same solution. So alpha y equals for a fraction, enter. And then we enter the same thing. -1 plus I root 3. As far as I know, there's no copy and paste on the TI-84, so we can't just copy that. Go to the denominator, close the parentheses, and don't square this one. We only square the first one because the equation said so. And now we add 1, and we want to see if this is equal to 0. If it is a solution to the equation. So, yes, it is indeed a solution. So we did all of our work correctly. Now what we could do is test the other one. Go up to what we entered, press enter, and it re-enters that in the new line. So now we can edit this press second left to go to the beginning of the line, and then we arrow right to the plus sign and change it to a minus sign. Not a negative, just a minus. And then we keep arrowing right to change the other plus sign to a minus sign. And when we press enter, if we get 0 again, it is the solution, and it is. So we did all our work correctly for that one as well. Okay, what I learned by making this video is that if you try to enter the function x squared plus x plus 1 into y equals, and then enter one of the solutions into that function, either graphically or by using the alpha trace button for the variables, it would not work. And that's, I think, just because those solutions don't show up on the graph or work inside the function. But it does work on the main screen in complex mode. So that's pretty sweet. Hey, I hope that lesson made sense to you, even though we don't live in an imaginary world. Well, except in video games. If you'd like to see some of my wife's visual effects, check out starkmade.com. The link is in the description. And if you like this video, be sure to give it a thumbs up. Thanks a bunch.